Okay, so now we've gone over all of the different properties for limits. Again, our goal here is to not graph functions. Now you can always graph the function, but our goal is to not graph the function but still evaluate the limit. So let's do some examples. So we're going to start with this first one. The limit as x approaches 2 of x squared plus 5x plus 3. So here I'm adding 3 different things, so I'm going to go to the next line. And I'm going to break this up into a sum. So this will be the limit as x approaches 2 of x squared, then plus the limit as x approaches 2 of 5x, and then plus the limit as x approaches 2 of 3. So I took my sum that I started with and I broke it up into 3 different pieces. Now what can I do with each of these? Well, my first one, I have x to a power. So I'm going to bring that power to the outside. So I'll have the limit as x approaches 2 of x, and then my squared is now on the outside. What about this next one? Here I have a constant times x, so I'm going to bring that constant out. So it'll be 5 times the limit as x approaches 2 of x. And then the limit as x approaches 2 of 3. 3 is just a constant, so it's always going to be that constant, so there's nothing I can do with that. Now let's evaluate this even more. The limit as x approaches 2 of x, that's just 2, then I'm squaring it. Now I have 5 times the limit as x approaches 2 of x, that's just going to be 2, and then plus 3. So I have 4 plus 10, which is 14, plus 3 gives me 17. So that tells me that the limit of my original polynomial is just 17. Let's go to our next example here. I'm looking at the limit as x approaches -1 of the function x plus 1 squared over x minus 1. So here I have a quotient. So remember with quotients, what I was able to do was to break it up into a fraction with 2 limits. The top limit is going to be my top function, so the limit as x approaches -1 of x plus 1 squared, and then on the bottom I'll have the limit as x approaches -1 of x minus 1. Now what am I able to do with this? I'm able to bring this power out front, or out on the outside here, so I'm still going to have my quotient. If I do this, I'm going to have, let's get our parentheses right, I'll have the limit as x approaches -1 of x plus the limit as x approaches -1 of 1, and then my squared is going to be on the outside. So I use the sum rule and the power rule on this one. And then on the bottom, I can break this up as a sum, so I'll have the limit as x approaches -1 of x, and then plus the limit as x approaches -1 of -1. Okay, now let's see what we get. I'm still going to have my quotient. So on the top, I have the limit as x approaches -1 of x, that's going to be -1. The limit as x approaches -1 of 1. 1 is a constant, so it doesn't matter what x is approaching. I'll still have 1. And then that's squared. And then on the bottom, I'll have the limit as x approaches -1 of x, that's -1. And then the limit as x approaches -1 of -1, well, -1 is constant, so I get -1. Now what is this equal to? On the top I'll have 0 squared, on the bottom I'll have -2. 0 divided by -2 is 0. So that tells me that the limit of my original problem, the limit of my original quotient is just 0. So maybe we want to write that there, just 0. Okay, now let's try the root one. So here I have the square root of 2x squared minus 5x plus 4, and I have x is approaching 0. So what I can do with this is I can take that square root and put it on the outside. So this is going to be the limit of just my other function. So 2x squared minus 5x plus 4. So whenever you have a power, remember that a square root is just a power, it's the power of 1/2. I can bring it to the outside. Okay. Now what can I do? Now I have a sum and some quotients and powers. So what I'm going to do is rewrite this. I'm going to have a bunch of limit as x approaches 0, so let's see what I can do with that. So the first term, that's going to be 2 times the limit as x approaches 0 of x, and then squared. Next, I'm going to have minus 5 times the limit as x approaches 0 of x, and then lastly plus the limit as x approaches 0 of 4. So I took this polynomial and broke it up using my constant multiple and my powers. Now let's evaluate it even more. So my first one, 2 times the limit as x approaches 0 of x and then squared, will be 2 times 0 squared. The limit as x approaches 0 of x, that's just 0. And then lastly, the limit as x approaches 0 of 4. 4 is just a constant, so it's just going to be that constant. Last step, this is going to be 2 times 0 is 0, minus 0 plus 4. And what is the square root of 4? That's 2. So the limit of my original function is just going to be 2. Okay, now let's look at this last one. Here I have a quotient, so I'm going to try to break this up as a quotient. So I'm going to have 2 parts of it. The first part is going to be the limit as x approaches negative 1 of my top one. And the second one is going to be the limit as x approaches negative 1 of my bottom. Now let's look at the bottom for a second. I'm going to leave the top as it is because I think we're going to see something interesting on the bottom. So this is still x minus 1 on the top. When I break this up, what's going to happen? When I break this up, I'm going to have the limit as x approaches negative 1 of x, and then plus the limit as x approaches negative 1 of 1, and then the whole thing is going to be squared. So let's evaluate what that is. So again, not doing anything to the top, let's ignore that for right now. It's still going to be the limit as x approaches negative 1 of x minus 1. What do I get on the bottom though? Well, the limit as x approaches negative 1 of x, that's just negative 1. The limit as x approaches negative 1 of 1, 1 is a constant, so it doesn't matter what x is approaching there. And then I'm going to be squaring this entire thing. Whoops, not square there, squared on the bottom. Well, what have I just done by putting a negative 1 plus 1 in the denominator? So I'm dividing by 0, which is bad. So we say this does not exist, or it's undefined. Oops. So there's no answer to this one because we're dividing by 0. So the quotient only works when I'm not dividing by 0. So what we would say to this problem is that it's undefined. Using the tools that we have currently, we can't evaluate this. Oh, not that one. This one. We can't evaluate this. We might develop tools later to figure out how to do this, but for now, because we were dividing by 0, there's nothing we can do. So it's undefined. Now, one thing that we should look at is for any constant c, the limit as x approaches c of some power is just c to that power. The answer is why. Well, that's because, what is this really? If I have the limit as x approaches c, I could make this just x and then put the whole thing to the power of p over q. So this is to the power of p divided by q. So anytime I have a power, remember I can bring it to the outside. And now what is the limit as x approaches c of any x? That's just c. So this is just c to the p over q. Now how does that help us? This is going to help us with polynomials. So instead of having to go through all those steps, for polynomials you can just kind of use what we have. So for now, those are the examples that we're going to do. Just remember to use all of your different rules, and that way we won't have to graph everything.